From the vantage of space, Earth is a turning sphere wrapped in air and light, completing one rotation every 24 hours and circling the Sun at more than 67,000 miles per hour. The Sun itself sweeps around the Milky Way in an immense arc, carrying the entire solar system through the galaxy at nearly 500,000 miles per hour. Yet in the midst of this vast celestial motion, we feel nothing at all. The coffee in its cup does not tremble. The atmosphere rests gently across mountains and sea, and the rhythm of our own pulse remains unperturbed. Motion surrounds us, but we live within its perfect silence. This apparent stillness, so ordinary and constant, is one of nature's most subtle illusions. It arises not because movement ceases, but because we belong to it. Like passengers on a smooth-flying aircraft, we do not sense velocity when it is uniform. The principle behind this is inertia. An object continues in its state of motion unless acted upon by an external force. When the entire planet and everything upon it move together at the same steady rate, no internal difference reveals the speed. There is no push, no pull, no acceleration to register in our senses. We are carried in a single unbroken glide. The human body is built to perceive change, not constancy. The inner ear detects acceleration, sudden tilting, or vibration, but it has no register for a planet's steady spin. Our experience of motion is therefore limited to what interrupts the uniform. The beginning of a train's departure, the lurch of a car as it brakes, the sway of a ship at sea. These are the moments that make motion visible. In the absence of such cues, our physiology interprets equilibrium as rest, even while we travel at cosmic speed. The gentleness of this hidden movement can be demonstrated by instruments more sensitive than our senses. In 1851, the French physicist Léon Foucault suspended a heavy pendulum from the dome of the Pantheon in Paris. As the pendulum's weight traced its path back and forth, the floor beneath it turned imperceptibly with the Earth's rotation. Over several hours, the plane of the swing appeared to shift, not because the pendulum changed, but because the world did. That slow drape of motion on marble became the first public proof of our planet's spin, displayed not through noise or force, but through exquisite stillness. Uniform rotation is one of the essential conditions that shaped Earth's stability. It determines day and night, drives weather, and powers the planetary magnetic field, a shield produced by the circulation of molten metal deep within the core. Without that internal rotation, the planet would lose its protection from the sun's charged particles, and life would be stripped away, molecule by molecule. The steady spin that feels like calm to us is, in reality, a vast engine maintaining the world's equilibrium. Even this constancy is not absolute. Over immense spans of time, the moon's gravitational pull acts as a delicate brake, transferring angular momentum from Earth to itself. The effect is almost imperceptible. Each century, the length of a day increases by just under 0.02 of a second, but it accumulates. When the first forests covered the continents, a day lasted little more than 22 hours. In another 100 million years, it will lengthen again. Motion slows, yet never ceases. The planet and its satellite exchange energy in a ceaseless negotiation. The broader universe displays the same pattern on every scale. Stars condense from turning clouds of interstellar gas. As a cloud collapses under gravity, the conservation of angular momentum makes it spin faster. The resulting star and its planets inherit that spin, each becoming a miniature record of the original rotation. Our Sun completes one axial turn every 27 days, carrying magnetic fields that sweep through the solar system like luminous ropes. Entire galaxies obey the same law. The Milky Way revolves once every 230 million years, forming a rotating spiral pattern that has persisted since before the Earth was born. Motion is not the exception but the foundation of matter itself. At the smallest dimensions, rotation remains inseparable from existence. Electrons, protons, and neutrons possess intrinsic spin, a quantum property that determines how they combine to form atoms and molecules. This spin is not rotation in the classical sense, but an inherent form of angular momentum built into the very equations that describe the structure of matter. Every atom on Earth contains within it that fundamental motion, the same mathematical rhythm that governs stars and galaxies. From the subatomic to the cosmic, the fabric of reality is threaded by rotation. Given this universal motion, the persistence of stillness in perception might seem paradoxical. The answer lies in relativity. Einstein's theories demonstrated that all motion is relative to a chosen frame of reference. There is no absolute rest, no universal background from which velocity can be measured independently. To an observer on Earth, the world appears stationary, and it is the heavens that turn overhead. To a distant observer drifting freely in space, it is the Earth that spins beneath. Both viewpoints are valid within their own frames. Neither possesses a privileged truth. Stillness is simply motion experienced from within. This relativity is confirmed every day by astronauts orbiting above Earth. At 17,000 miles per hour, they circle the planet every 90 minutes, watching 16 sunrises in a single terrestrial day. Yet inside the spacecraft there is no sensation of speed. In microgravity, without air resistance or vibration, velocity becomes irrelevant. As in all uniform motion, when everything moves together, nothing seems to move at all. The constancy of Earth's rotation defines the measure of time itself. The 24-hour cycle we divide into minutes and seconds is drawn directly from the planet's turning. Atomic clocks now provide greater precision than celestial observation, but even those instruments rely on rhythm, a microscopic echo of planetary regularity. The measurement of time, from the swing of Foucault's pendulum to the oscillation of atomic energy levels, is a refinement of how we mark rotation. Time and motion are not merely connected, they are the same principle observed from different perspectives. The concept that we inhabit a still world in motion serves not only as a scientific fact, but also as a philosophical reflection. It demonstrates that perception is bounded by participation. Because we are part of the motion we seek to measure, its smoothness conceals itself from us. The Earth's rotation has defined every second of human history, yet no one has ever felt it directly. The very stability that allows us to build cities and measure the stars exists because friction is absent and speed is constant. This quiet equilibrium may also explain why the idea of movement fascinates our imagination. Humanity has long looked upward to watch the heavens shift, seeking significance in the orbits of planets, the rising of constellations, and the steady return of the seasons. Ancient astronomers built calendars and temples aligned to the sky's apparent rotation, recording in stone the imperceptible motion beneath their feet. The illusion of stillness inspired the search for truth, and ultimately revealed that we live upon a planet in continual revolution. Beneath this revelation lies a deeper unity. The rotation of Earth, the orbit of the Sun, the spin of galaxies, and the innate angular momentum of particles all express a single continuity of physical law. Motion does not begin anew at each scale. It transfers, conserved from the birth of the cosmos, to the smallest particle of the human body. When silence seems to hold the world, that silence is not the absence of movement, but the synchronization of countless motions too consistent to detect. In every direction, the evidence surrounds us. The tides rise and fall according to the moon's orbit. The stars wheel across the night sky at the rate of 15 degrees per hour. Satellites trace their invisible highways overhead with mathematical precision. Clocks on the equator run imperceptibly slower than those at the poles due to the difference in rotational speed and gravity. Every measurement confirms that we are embedded within a universe whose fundamental state is perpetual rotation. Yet, within this immense dynamism, there is grace. The systems endure because motion is balanced by order. The forces that drive the planet's spin also preserve its stability. The motion of the galaxy does not rend the stars from their place, but binds them in vast spirals defined by gravity and inertia. Stillness, then, is not illusion in the sense of deception, but in the sense of harmony, an equilibrium in which movement is distributed so evenly that it becomes invisible. What we call calm is the synchrony of universal motion. When one contemplates this balance, the awareness of motion becomes transformed. The recognition that every cell, every ocean current, and every drifting stone is carried within a continuous planetary rotation can redefine stillness itself. The quiet at this moment, the pulse steady in the wrist, the unmoving horizon, all are expressions of motion so perfect that disturbance disappears. Earth's spin will continue to slow, its tides to move, and its orbit to carry us around the sun long after humanity has ceased to observe. The universe will keep turning, advancing in cycles immeasurable by any single life. Our experience of stillness will remain anchored not in absence of movement, but in unity with it. We are passengers in a ship that will never stop sailing, inhabitants of a planet that will never truly rest, participants in a cosmic rotation that began before memory and will continue beyond imagination. The stillness we feel is the soundless harmony of everything moving together, a balance so complete that it feels like peace.